Okay fellas, so now we're going to kick off with annuities. Now the difference between annuities and basic compound interest is that annuities means there's a regular investment into a fund. So every year, for instance, at the beginning of each year you might invest $1,000 each year, and they will earn different amounts of interest depending on how long they're in the fund. Right, so we'll kick off with example 1. Now example 1 says a sum of $1,500 is invested at the beginning of each year in a superannuation fund. Superannuation fund is just a sort of retirement savings fund. If interest is paid at 6% per annum, how much money will be available at 25 years? So again, I'll emphasize, you're putting in $1,500 at the beginning of each year. It's not just one payment, you're doing it again and again. Okay guys, just before we start, this is the formula you'll need for doing any annuities and also loan repayments. You'll need the sum of a geometric series, which of course is a outside of r to the n minus 1 over r minus 1. The ratio will always be greater than 1 in this case, so you won't need to worry about the bottom one there. So just the top one, but you'll need that, so keep it on hand. Okay guys, so having a crack at this. Annuities, regular investments each year. Example 1, we're investing at the beginning of each year. Okay, so there are two different types really, the beginning of each year or at the end of each year. So we have $1,500 per year, interest is 6% per annum, n equals 25 years. So what we're doing is we look at first year. We invest $1,500 at the start of the year, and that earns 6% interest times 1.06. Okay, in year 2, we have this amount already in the account. At the end of year 1, we invest $1,500 at the beginning of year 2. Now over year 2, that is going to earn interest. It's 1.06 interest. Okay, so this times this is 1,500 times 1.06 squared plus 1,500 times 1.06. That is A2. Okay? Now what we're saying there is that the first $1,500 we invested has earned 2 years of interest. The second $1,500 we've invested has only earned 1 year's interest because it's only been in there 1 year. Now, A3, we have all of this in the account. So I'll write that out. Now we invest another $1,500 at the beginning of year 3, and all of it earns interest. So we have 1,500 times 1.06 cubed plus 1,500 times 1.06 squared plus 1,500 times 1.06. Okay, and there's a power of 1 there, but we don't need to write it. But now we don't want to do that 25 times. So what we do is after doing 3 years worth, we write down ... down to A25, and this is about recognizing patterns. And what we see is it's 1,500 times 1.06, 3. We have 3 years there, it's power of 3 there, 2, then power of 1. So this will be 1,500 times 1.06 to the 25, 25, 25, 3, 3, plus 1,500 times 1.06. This is 1 less than that power, to be 24, plus ... 1,500 times 1.06 to the power, the last one is going to be 1. Okay. Now, just explaining this. The first investment will have had 25 years of interest. The second investment will have had 24 years of interest. The final investment, so when we put that in the 25th year, it will get 1 year worth of interest till the end of the 25th year, and that is that one there. Okay, so how do we solve this? Right, we have 1,500, take it out the front, and we have this, all the way down to 1. Now I'm going to write this one first. 1.06 to the power of 1, plus 1.06 to the power of 2 is in here, plus ... plus 1.06 to the power of 24, plus 1.06 to the power of 25. Okay, now this is a series. So when we want to work out what A25 is, we can do this as a series. Now, in this series, A, the first term is 1.06. R, it's a geometric series because we're multiplying to get from this term to this term. The ratio, R, is 1.06 as well. So the sum of this geometric series will be A, 1.06, outside of, and it's 1.06 R to the power of n. Now how many terms are there in this series? We started at 1, we got up to 25, there are 25 terms in the series, minus 1 over 1.06, which is R, minus 1. Okay, now that is the total of this series. So A25 will be that times by this amount. So I'm going to work out this amount first just to make it easy. So the sum to 25, sorry I've put n there, but really it's the sum to 25, equals. Pull out the calculator. Now I'm going to do this part first and save it. Minus 1, we all know what that is, but I'm going to do it anyway. Store it in A. N. 1.06 to the power of 25. Okay, that's this. Equals. Minus 1 equals. Okay, that is everything in the brackets. I'm going to times that by 1.06. Equals. And that is everything on top. Divide it by this thing, which we've stored. So I'm going to recall it from A. And we get 58.156 ... Now we need to store that because I'm going to store it in, well, we can store it in A, but we could store it in B as well. Store it in B. That amount is everything in there. So A25 equals 1,500, this, times by this, which we know is this amount. ... You must use the stored amount because otherwise you won't get the exact value. So it's, I've already got it there, so I can just go times 1,500 equals $87,234.57. So if you start saving now, fellas, you put away $1,500 each year for 25 years at a rate of 6% interest up there. 6% interest. After 25 years, you'll have a grand total of $87,234.57. Needless to say, I haven't saved that much yet. Hopefully you'll be better than I am. Good luck. Okay guys, so example number 2. An amount of $50 is put into an investment account at the end of each month. So this is the second type of example. It's where it's put in at the end rather than the beginning. If interest is paid at 12% per annum paid monthly, how much is in the account after 10 years? Okay, let's give it a crack. Okay guys, so like I said, we're talking about the end of each month. Okay, rather crucial here. We have $50 invested at the end of each month. It's 12% per annum, but they said invested monthly. So we're going to change that, divide by 12, and it's 1% per month. Okay. It's invested monthly, which means rather than 10 years, we have 120 months. Alright, so in month number 1, what happens? We wait the whole month, and at the end of month number 1, he invests $50. So that money does not earn any interest that month because it's invested at the end. Month number 2, we have the $50 that was invested at the end of month 1. That earns interest, 1.01 for the month. And then at the end of month 2, we add $50. Alright, month 3. All of this is there at the beginning of month 3. All of that will earn interest in month 3. So there is the interest in month 3. At the end of month 3, we will add $50. Beautiful. Okay, month number 4, I'm going to go one more. Oh, sorry. Let's just simplify month number 3. So we have 50 times 1.01 squared, that times that, plus 50 times 1.01 plus 50. Okay, we've already got the pattern, but we'll just do one more just to make it sure. So in month 4, we have all of this. Okay, all of that is there at the end of month 3. All of that earns interest. And then we add $50 at the end of month 4. Okay, so we have 50 times 1.01 to the power of 3 now, because that times that, plus 50 times 1.01 squared, that times that, plus 50 times 1.01 plus 50. Okay, so again, this hasn't earned any interest because it was only put in at the end of the month. Okay, so now we can start to find our pattern. So we'll skip down to M120, the end of 120 months. Now, it's 50 times 1.01. Now we have to look at what this power will be. In 4 months, the first one had only made 3 months interest. So in 120 months, it'll have 119 months worth of interest. Okay? When this is 4, and this is, well, that's 4, that's 3, so this is 120, that's 119. And then it goes 3, 2, 1, 0. So this one similarly will go down from 119 to 118. So it goes 120, this is only 119, and the second one is 2 less, okay, plus dot dot dot, plus 50 times 1.01, plus the last month, we'll put in $50. Okay, so what's happening here? This is the one we put in at the end of the first month, and it has 119 months interest there. This one was the second month, 118 months interest. This last one is the last month. At the end of the 120 months, we put in a payment, and that earns no interest during that time. Okay, so we'll factorize out the 50, and I'll do this quite quickly. I'm going to write this term first. Okay, so 50 times, it's just times 1, so that's 1, plus 1.01, plus, it'll be 1.01 squared, plus dot dot dot, plus 1.01 to 118, plus 1.01 to 119. Okay, so we want to add this up now. I'll keep that in the screen. So we need the sum for this. Now, the only thing is, the difference is here, compared to when it was put in the beginning of the month, our A is 1. Our R is still going to be the ratio between here and so on, which is going to be 1.01. So our sum, S to 120, will be A out the front, 1.01. Now, how many terms are there between here and here? Now, this says 119, but we actually know that's from here. There's 119 from here to here. There's actually 120 terms here. Okay? This is actually a bit more like the geometric series you'll be used to, with A being the starting figure of 1, and then the ratios start taking effect. So, there are 120 terms there, minus 1 over 1.01 minus 1, I'll write it out. Okay, now, that of course will be times 50 once we work it out, but let's work it out first. So pull in the calculator. Thank you to Miss Ho for lending me her calculator. It is 1.01 to the power of 120, that's there, minus 1 equals. Okay, I'm going to store that in A. That's that thing stored in A. 1.01 minus 1 equals that. I'm going to store that in B. Okay, it's 1 times that, so I'll just recall A divided by recall B equals 230.0386 dot dot dot. Now, of course, I'm going to store that because I have to use the exact figure. So, M120 equals, well, it just equals 50 times that amount, 50 times all that amount. So I have that amount there, I'm going to times it by 50, and the total is $11,501.93. Hey presto, that is how much we get. Aha! Enjoy, fellas, and you got a little cackle from Miss Ho.